Standard 7.RP.1. RP stands for ratios and proportions, and this standard is specifically about unit rates. Looking at this problem number 2, it says select all the rates that are unit rates. And a unit rate is just going to be able to be written as a fraction, and it's always over 1. So looking at each of these fractions, the second one is over 1, the fourth one is over 1, and the fifth one, 10 to 1, is like saying 10 over 1. Number 4, Jenny is knitting a blanket. She knits 1/3 foot of a scarf in 2/3 of an hour. How fast is Jenny's knitting speed in feet per hour? The order that you see what it's requesting is very important. Feet per hour. So when we see per, that means we're just dividing. So I'm going to take the number of feet, 1/3, and divide it by the amount of time we have, 2/3 of an hour. And I'm going to just divide fractions. So 1/3 divided by 2/3 is, we'll use same opposite switch, 1/3 times 3 over 2. The 3's can cross cancel, they'll both divide by 3. So 3 divided by 3 is 1, and 3 divided by 3 is 1. And we get 1 times 1, which is 1 for the numerators, and then for the denominators, 1 times 2 is 2. So her knitting speed is 1/2 of a foot per hour. That's the unit rate because it's over 1 hour. Number 11, a car drives 5.5 miles in 1/12 of an hour. What is the speed of the car in miles per hour? So we're going to start here with miles per hour. We're going to take the number of miles, 5.5, and divide it by the number of hours, 1/12. And so I'm going to divide 5.5 by 1/12. So I'm dividing a mixed number by a fraction, so let's start by changing that mixed number to a fraction. We'll go around the world. The denominator 2 times the whole number 5 is 10, plus the numerator 1 is 11. So we got 11 halves. Then we have 11 halves divided by 1/12. Let's change that same opposite switch to times 12 over 1. And then we could cross cancel the 2 and 12. They both divide by 2. So 2 divided by 2 is 1, and 12 divided by 2 is 6. And then multiply our numerators. 11 times 6 is 66. 1 times 1 is 1, which is just 66 over 1 is 66. So the speed of the car is 66 miles per hour. Standard 7.G.1, G is for geometry, and this standard is about scale drawings. It is going to use proportions like we would with ratios and proportions, so this one's grouped with the ratio and proportions unit. Now looking at problem number 2, it says on a scale drawing of a soccer field, 1/2 centimeter is equal to 7 meters. So the drawing is 1/2 centimeter, and that represents 7 meters in actual distance of the soccer field. If the drawing has dimensions 7.5 centimeters by 5 centimeters, what's the size of the soccer field? So we're going to take this first dimension, 7.5 centimeters, and let's find out how many meters that is. We know this fact, that 1/2 centimeter is equal to 7 meters. So I'm going to set up a proportion. We know that 1/2 centimeter would have the same value as 7 meters. So we're looking to find out for 7.5 centimeters how many meters x that is. Notice that the centimeters are both numerators and that the first fraction is the scale. So let's solve by cross multiplying. We're going to cross multiply 0.5 times x is 0.5x. We're going to cross multiply 7 times 7.5, and that comes out to 52.5. We're going to divide both sides by, We're going to divide both sides by 0.5 to get x by itself, and x is 105. So that means that that first dimension is 105 meters. Now we want to know about this 5 centimeters, and we're going to use that same scale. We're going to start, I'll just write it up a little higher, that 0.5 centimeters is equivalent to 7 meters in actual dimensions of the soccer field. And we're looking to see what 5 centimeters would be in actual dimensions of the soccer field, x. And so we can cross multiply. X times 0.5 is 0.5x. 5 times 7 is 35. Divide both sides by 0.5 to get x by itself. And 35 divided by 0.5 is 70. So we get that x is 70 meters. So the size of the actual soccer field is 105 meters by 70 meters. Number 4, if a pool measures 30 feet by 66 feet, what's the scale of the drawing shown? So this drawing is representing the pool, but this is a scale drawing. In reality, the pool, 5 by 11, the pool would be 30 feet by 66 feet. So we know that it's converting inches to feet, and we know it's getting larger. Let's see what's happening. Going from 5 to 30, what is happening? Well, it is multiplying by 6 to equal 30. We could check that over here with the 11. We're going from 11 to 66. Let's see what's happening. Well, that would also be multiplying by 6. So in both cases, we multiplied by 6 to go from the scale drawing to the actual pool measurements. Number 5, Kiko is planning a family trip from Miami to Orlando and then on to Tampa, looking at a map where 1 centimeter equals 20 miles. She sees that Orlando is 23.5 centimeters from Miami, and then Tampa is 4.2 centimeters from Orlando. How far will Jenny travel in total? Well, first she's going to travel from from Miami to Orlando. So we've got this first distance on the map. And then from onto Tampa, and so we have the second distance on the map. So we see them in centimeters, we need to change them to miles, and then add them together. So we know that 1 centimeter is represented by 20 miles, and 1 centimeter on the map represents 20 actual miles. So for Orlando, it's 23.5 centimeters on the map, and we want to know x, how many miles that is. And you could solve this using a proportion. Cross multiply. 1 times x is just x, and then 20 times 23.5 is 470. So we've got that first distance is 470 miles. Then we have, for going to Tampa, we know still 1 centimeter represents 20 miles. And we have a distance of 4.2 centimeters on the map. We're trying to find out how many miles x that is. So cross multiply. We've got x equal 20 times 4.2, which is 84 miles. And so to get that total, we're just going to add them together. 470 plus 84 is 554 miles. Answer choice A. Whoops.